This session is on purity and formulations. By the end of this session, you'll be able to define what pure means in chemistry. We'll be able to describe how melting point ranges are used to measure purity. And we'll be able to describe what formulations are with some examples. In chemistry, a pure substance is made up of one element or one compound. So pure water will only contain H2O, it won't contain anything else. Pure oxygen will only contain O2, nothing else. When we talk about bottled water, we can't class it as pure in chemistry because it contains calcium, magnesium and so on, all these other elements, all these other compounds inside it. We can't call it pure. If it was pure, it would only be made out of water, H2O. The same thing goes for drinks like orange juice and so on. Supermarkets may say that they're pure, but if you look at the ingredients, if they're not made of only one type of substance or one substance, we can't class them as pure in chemistry. To check for the purity of a substance, we need to look at its melting point and boiling point ranges. So purity is based on fixed points. The fixed points in chemistry are melting points and boiling points. These both have ranges. The smaller the range, the purer the substance. Now, a pure substance would have a sharp melting point. For example, water, the melting point is 0 degrees Celsius. So pure water would melt at 0 degrees Celsius. Because of small impurities, it does have a range sometimes when it becomes a mixture. Pure substances have sharp melting points like I mentioned. Mixtures have a range of melting points. The smaller the range, the purer the substance. The bigger the range, the less pure the substance. This here is called a melting point apparatus. It's full of oil here, and the reason why it's full of oil is that when we heat this up, if the substance that we're trying to work out the melting point for is above 100 degrees, if water was inside here, it would have evaporated. The oil has a much higher melting boiling point. Okay, so it won't turn into a gas quickly because the boiling point is a lot higher. The rubber band that's attached keeps the thermometer attached to the melting point source. Okay, the capillary tube is a very small tube that we place our sample in. Okay, there's an opening to allow air out the apparatus. If the air isn't allowed out the apparatus, pressure will build up and this will just blow off the end. The thermometer is really important. It tells us the point at which we find the boiling point. Okay, so we'll identify the temperature either in degrees Celsius or Fahrenheit, depending on where you are. Right, let's look at an example. Caffeine has a melting point range of 234 to 237 degrees Celsius. So if we work out the range, if we take the smallest number away from the largest number, we end up with a melting point range of 3 degrees Celsius. Okay, so that window is quite small. If we look at these three samples of caffeine, we can work out which one is the purest. So the range for the first one is 12 degrees Celsius. The range for the second one is 39 degrees Celsius. And the range for the third sample is 8 degrees Celsius. So the purest of the three is the one with the smallest range, so therefore it's sample 3. The most impure one is sample 2. We use formulations in every day in our lives. Okay? We need to know what they are. They're common in exam questions. Formulations are mixtures with a desired purpose. Okay? Loads of things are mixed together in a formulation to find desired properties. Now companies guard these with their lives sometimes. Example, the Coca-Cola company don't give out their formula for Coca-Cola because it makes them a lot of profit. KFC don't give out their formulas for their chicken because it makes them a lot of profit. We'll look at a common formulation, washing up liquid. Now we know that what we want from washing up liquid, we want to get the grease off plates and dirt off plates. These things are added. So surfactants are added These are detergents that remove the grease. Water is added to thin out the mixture. By thinning out the mixture, we can make it last longer. Same reason why water is added to paint, or solvents are added to paint. We want it to last longer, to cover a bigger surface. We have a rinsing agent. This allows the mixture to come off the dishes themselves. And then we can add a color or fragrance. Now, colors and fragrances are added just purely cosmetically. We make them more appealing for customers to buy. Right, let's look at some examples of some more formulations. So pesticides and herbicides. So drugs companies, pharmaceutical companies can actually create pesticides and herbicides that will target specific animals or specific plants. Pharmaceuticals industry uses formulations to make their drugs. Now, when you're creating a simple paracetamol tablet, it will contain the active ingredient acetaminophen, but it will also contain other things like talcum powder. It will contain things like gum, or if you're trying to put a capsule around it, that will have gelatin around it rather than the actual tablet made of talc. Petrol and diesel, we need to take out the lead from petrol to make it better for the environment. We can add alcohols to the fuels now to make them burn better and better for the environment. Cosmetics, we can make different shades of cosmetics, we can make different textures of cosmetics based on formulations.